Hey everybody, what's going on? Today we're talking about 1.3, that is systems of simultaneous equations. The essential question is, what is your preferred method for solving a system of equations in math? We're starting to get into a little bit more advanced algebra stuff here. We're solving for two equations at the same time, right? And so there's a lot of different ways to perform algebra tasks, and we want you to be able to do that. Now, a lot of word problems emphasize this skill, and it's pretty popular in the IB exam, so we want to address it. Now, many word problems are difficult to conceptualize, but with a keen understanding of algebra, you can make very quick work of them. Let's take a look at a general example first. A word problem you might be confronted with. You love bananas and limes. You, in fact, buy bananas and limes every day. You forget how much each costs, though. The only thing you do remember is that the last 2 times you went to the store, you bought 5 bananas and 4 limes. Your total was $2.11. The next time you went to the store, you bought 10 bananas and 3 limes. And your total was $2.77. Now you can set up a system of equations to find out how much a single banana and lime cost without going to the grocery store again. And we do that with a system of simultaneous equations. Let's go ahead and let x equal the cost of a banana and y equal the cost of a lime. So let's see how we represent this scenario. The first time we went to the store, we bought 5 bananas, so that's 5 times the cost of banana x, and 4 limes, adding that together. 5x plus 4y, and that gives me a total of $2.11. Okay? The next thing we can look at, though, is what happened the second time. You bought 10 bananas, so that's 10x, and 3 limes. So 10x plus 3y, and our total was $2.77. Okay? And then we put a funny looking brace around this. It's like a fancy parentheses, right? It looks like this. Okay? Now, it took me a long time to figure out how to actually draw these. You'll struggle with it. It looks weird. Kind of think of like a super fancy E, and you'll almost be there. Alright? Now, this is just showing that these two things exist simultaneously, and hopefully there's going to be a solution for them. Now, how do you know you're going to be able to actually find that solution? Well, as long as you have as many equations as you do variables, you can solve the system. So here we have 2 equations and 2 variables. And as long as those 2 numbers are equal to each other, then we can solve it. Okay? Now, this kind of word problem, again, this is what we will be working toward. But before we even get to a problem like this, we're going to kind of take a step back and look at the pure algebra approach and practice all the different ways that we can solve a system of simultaneous equations with 2 equations. All right? Let's go ahead and do that. What are the different ways that we can solve a system of simultaneous equations? Well, we can graph, do substitution, or elimination. Each has their advantages. You usually will get to choose whichever method you want. So let's take a look at an easier example than dealing with one of these weird decimals. We'll come back to bananas and limes next time. Example 1, we have a system of simultaneous equations that's 4x plus 3y equals 9, and x minus 3y equals 6. Well, what does it even mean to solve a system of equations? We want to solve for x and y, which means we want to know what does x equal and what does y equal that will work for both of these equations. Okay? Well, step 1 is going to be graphing. So solving by graphing is easy when you happen to have a graphing calculator. Now for me, I'm using a laptop device right now, so I can use Desmos or something like that. What are your solutions going to be? Your solutions are going to be the x and y coordinates, right? Your x coordinate is your x solution, your y coordinates are the y solution of where these lines intersect. So we want to look for the intersection, all right? So let's go ahead and do that for this example. I'm going to open up Desmos on my screen here so you guys can take a look. And I'm going to type in the equations that we had. 4x plus 3y equals 9. And then the other equation that I had was x minus 3y equals 6. X minus 3y equals 6. So here we see we've got our 2 graphs. And look at how easy this is when you have a graphing calculator. That's where these 2 lines intersect. They intersect at the point 3, -1. So that's my solution. Can I just write down x equals 3 and y equals -1? Not exactly, okay? But that is our solution, so we can go ahead and at least write it down. X equals 3 and y equals -1. But what do we actually have to do? you always have to at least sketch your graph. That's not too hard, okay? It doesn't have to be perfect. If all you're trying to do is like show your work here, unless you're specifically told to graph or draw a particular set of lines to find a solution, and this is your choice, you can just make a sketch. So what I want to do is I want to just look at where do these things intersect. Well, the first thing I know is they intersected at the point 3, -1. So I'm going to go ahead and plot the point 3, -1. That one's a little bit off based on my scale. So here's 3, -1. That's where the two lines are going to intersect. And now looking back here, I had one of these lines. It's my blue one, x minus 3y equals 6. Cross my y-axis at 0, -2. So here's one of my lines. And this is the line x minus 3y equals 6. And then I'll look at my other one. Where did my other one cross the y-axis? It crossed the y-axis at 0, 3. So I'll go ahead and plot that point, 1, 2, 3. And then we will connect going through there. This is the line, 4x plus 3y equals 9. It's always a good idea to actually state the lines that you're sketching, so that way somebody can really understand what it is you're trying to do. And this is the intersection point. And there is good enough for showing your work. And we say, since the lines intersect at 3, -1, it has a solution. If the lines didn't happen to intersect, we would actually have no solution. So parallel lines, unfortunately, they're not going to end up having any solutions. Okay, but if they do intersect, then they've got solutions. And there we go. So at this point, go ahead and pause your video to try and do example number 2 on your own sheet of paper. Unpause when you're ready to move on to the next way that we can solve a system of equations. So our next way is to solve by substitution. Now, when do we want to do this? Well, we want to solve by substitution when one of the variables in the system is already isolated. Okay, that's the key part. Do we have a variable that's isolated? What does it mean to be isolated? Let's go ahead and take a look down here at this example. X is all by itself on the left-hand side of the equal sign. That means it's isolated. Okay? So you'll notice that this is actually the exact same system of equations. I just moved that -3y over to the right-hand side of your equal sign. Okay? So now, what's our first step? Take the expression of the isolated variable. Okay? Step number 1 is to take the expression of the isolated variable. Well, this is the expression of the isolated variable where x is isolated. 3y plus 6 is the expression. And we want to substitute in for the same variable in the other equation. My other equation is this, 4x plus 3y equals 9. Now, what's cool about substitution is the power of the equal sign. Anywhere you see that equal sign means anywhere you see x, I can substitute it in for with 3y plus 6. So instead of 4x plus 3y, I'm going to say 4 times 3y plus 6 plus 3y equals 9. Okay? So now I've substituted that in. Now look what is important about that. We have one equation with just one variable. The only variable now we have to be concerned with is y. Let's go on to step 2. Solve for the lone variable. My lone variable in this case is y, so let's go ahead and distribute through, giving us 12y plus 24 plus 3y equals 9. Okay? Now we want to solve for that variable. Let's simplify and combine like terms. I now have 15y plus 24 equals 9. If I subtract 24 from both sides, I'm left with 15y on the left side, and I'm left with -15 on the right side after subtracting 24 from both sides. Move over here to show where I'm at now. Next step is to divide both sides by 15, and we will end up with a simplified y equals -1. There's one of our solutions. And sure enough, that was one of our solutions, y equals -1. Same exact way, same system of equations that we solved by graphing, you'll get the same solution set here. So how do we know that x is going to equal 3? Well, let's move on to step number 3. Step 3 says, use your solution from step 2 and plug it into either equation to find your solution. Well, I like the second equation, x equals 3y plus 6, because x is already by itself. That's less for me to actually manipulate and move around. It's less algebra to do. So now I just have to use my solution that I got where y equals -1, and wherever I see y, I'm going to replace it with that. And now we have x equals -3 plus 6. Adding those two together, we get x equals 3. And there's our second value. And we indeed get the same exact set of other solutions, x equals 3 and y equals -1. Okay? Next thing I'd like you to do is try with this set of equations, try to solve by substitution. Go ahead and pause the video to try your hand at example number 4. Unpause when you're ready to learn the next step. Our next example is going to show you a way to solve by elimination. When do we want to use elimination? Well, we want to use elimination, when you have opposite coefficients. So for example, in one of our sets, we had a positive 3y and a negative 3y. That's going to be what we would want to, when we would want to do this. So actually, I have the wrong setup right here. Let me rewrite the equation as it was originally. This was my original system. 4x plus 3y equals 9. X minus 3y equals 6. This is actually really handy because we have the same coefficient for y, but they are opposite in number. 3y versus -3y. Same size, opposite sign. So what we want to do first is step 1, make sure your variables and constants are all lined up on top of each other. Perfect. Done. Step 2, your result should, actually, this is really kind of step 2, is we need to add the equations, and then your result should eliminate a variable. So let's go ahead and add these two equations. Okay? Adding these two equations, we have 4x plus 1x is going to give us 5x. 3y minus 3y, those eliminate. They cancel each other out, right? We get 0y, and then we have 15. Now we're on to step 3, solve for your lone remaining variable because the y's are now eliminated. Dividing both sides by 5, we get x equals 3. Okay? Step number 4, use your solution and choose an equation to plug it into. Doesn't matter to me whichever one you want to use. I like the second one because it's just 1x minus 3y. So I have 1 times 3 minus 3y equals 6. 3 minus 3y equals 6. Let's go ahead and subtract 3 from both sides, giving me -3y equals 3. And then the next thing we do is divide both sides by -3, and we get y equals -1. Do those solutions look familiar? They should, because it's the same system, so we end up with the same solution regardless of the way that we solve it. X equals 3 and y equals -1. Okay? What I'd like for you guys to do now is also try solving by elimination. In example number 6. Pause the video at this time. Try it on your own. Unpause when you're ready to look at the last example. All right, example number 7. Sometimes solving by elimination requires you to manipulate the equations in order to get coefficients of one of the variables to be the same size, but opposite in sign. So if you look at this example here, we don't have a variable isolated. No isolated variable. Okay, if we have no isolated variable, then we do not want to do substitution. No substitution, that's out. Okay, let's say I have no graphing calculator. My GDC is broken. That's sad. I can't graph these lines without my GDC. I'm sure you could, and that might be an easy way to do it, but let's just say, for example's sake, you are prompted to do elimination. If we have to do elimination, okay, let's see what we want to do. Our first step is thus, try getting the x or y coefficients to be the same number but opposite signs. That's what we need to have in order to make this happen. So how do we do that? Okay, well, which ones do we want to work with? Do we want to work with the x's or the y's? What we want to think about here is really like what are going to be some least common multiples that we want. Okay, so when I look at least common multiples, the least common multiple between 10 and 70 is not going to be, or 10 and 7 is not going to be until 70. But 2 and 3, my least common multiple there is going to be 6. So watch what happens here. We're going to manipulate this in kind of a fun way. It's a little bit different. What we want to do here is I'm going to multiply everything in this first equation, multiply everything by 3. Equation number 1, we are going to multiply by 3. And equation number 2, we're going to multiply everything by 2. As long as we, actually I'm going to multiply by -2. Okay, and you'll see why in just a moment. Okay, as long as I multiply the entire equation by the same factor, we're not changing the essence of the equation, and it's a perfectly allowable way to go about solving this set of equations. Okay, so for the first one, we're going to go ahead and multiply everything by 3. 2x times 3 gives me 6x. 10y times 3 gives me a positive 30y. And then -5 times 3 gives me a -15. Next, we need to multiply equation 2 by -2. So 3x times -2 gives me -6. -7y times -2 gives me a positive 14y. And then 9 times -2 is going to give me -18. So why did I change it to -2? Because now, look what I have with 6 and negatives. I have 6x and I have -6x. So now what can I do? That's really handy. We can now add equations to eliminate a variable, just like we did in the previous one. So now it's set up in the same exact way that we had the previous one. So adding these two, 6x minus 6x gives me 0x, and then I have 44y. And we look at the next one, -15 and -18. That's going to give me -33. Now we just need to solve for y. These numbers look gross. Don't worry, trust yourself. You did this the right way. Divide both sides by 44. And we get -33 divided by 44. Hopefully you recognize these have the same common factor, which means they will reduce. I can divide both of these terms by 11, and I get y equals -3/4. And there's one of my solutions. Now, you're perfectly within your rights, if you want to write this as a decimal. Let's go ahead and do that, -0.75. And that might be an easier way to go about this, is to actually work with decimals. It's totally up to you. Sometimes I like fractions, sometimes I like decimals. Now, what do we need to do? Well, it's the same kind of process that we did in the previous example. Once we have one solution, now you want to plug solution in to either equation and solve for remaining variable. Okay, so once we've done that, let's go ahead and take a look at what we have. If I plug in, I'm going to plug in to the first equation because I kind of like multiplying things by 10. That seems like it's a little bit easier for me. So I have 2x plus 10 times -0.75, and that's going to equal -5. Let's go ahead and simplify. We have 2x minus 7.5. 10 times -0.75 gives me a -7.5 equals -5. I'm almost out of room, so I'm going to go over here now to finish up. Let's add the -7.5 to the other side, so that way we're adding 7.5 to both sides. That eliminates the 7.5 from the left side. And now we have -5 plus 7.5. -5 plus 7.5. I'm going to write it out here just because I'm almost getting lost a little bit myself with the addition here. Okay, now I can see clearly my signs, which number is bigger, and that gives me 2.5. Okay, now divide both sides by 2, and we have 2.5 over 2. Well, we don't like mixed fractions like this where we have a decimal and an integer, right? If we're using fractions, use whole numbers. If we're using decimals, don't use fractions. So let's go ahead and simplify this. Just go ahead and divide it. 2.5 cut in half is 1.25, and that's my solution for x. So now I have my solution for x, and I have my solution for y. And that's it. So I want you guys to try your hand on the next one. Solve number 8 by elimination. Once you guys are done, just please make sure you keep these notes, have them ready for your next lecture in class, and we'll see if you guys have any questions at all over any of these examples, and I'll be happy to go over any of those results with you. All right, have a wonderful day.